Hello, good afternoon, everybody. My name is Valentine Venus. I work for Ramani together with ESA, ESRIN, and other organizers and content mentors. We are very glad that you are joining us in this session covering the Space AppCamp 2021. Ideating Edge AI for Earth observation in 8 weeks. The results from this year's iteration. We will go through the following. So we'll spend a few minutes and Anna will kick this off introducing the Space AppCamp, then the Philops role by Nicolas Longepe, building the Space App in 8 weeks, where I will be briefly touching upon the technical and the thematic content mentoring and business development. Then we have 3 pitches of the most promising results of this edition, the 2021 edition, in order of Wildfire, Float, Fortisky. Then we have a bio break or overflow from the previous, depending on how strict we stick to the timing. Then Pierre Di Vito will introduce us how we can take the results of an app camp and an ideation event like this and start scaling up business ideas around space. Wrapping up with a Q&A, we all would like to give a warm welcome to Anna. Anna, who has been leading the app camp this year, having a lot of innovative inputs to make it even better. Anna, the floor is yours.
Thank you, Valentin, and good evening. My name is Anna Buzhukowska, and I work at the ESA Copernicus office. The Copernicus office has been a home for the AppCamp for the past 10 years, and indeed, we continue to support this important initiative. I wanted to welcome everybody at the site event, which is organized together by ESA, AZO, and Ramani, and actually, as Valentin mentioned, dedicated to showcase the results of the ESA Space AppCamp 2021. Today's session is about ideating at the edge, or about innovation at the edge, and this title could be a motto for the evening because it actually has 2 meanings. So on the one hand, innovating at the edge is about embracing new ideas, new technologies to create new products, new services. But innovation at the edge also means using, it's a technical term, is actually using edge devices such as smartphones that can process, transmit, display data both on local devices and on the cloud. So these 2 definitions taken together describe very well what the ESA Space AppCamp is about. For those of you who don't know the competition, Space AppCamp is an ESA initiative that is meant to stimulate development of EO-based applications and services on mobile phones or mobile apps, hence the name Space AppCamp. The competition has been ongoing since 2012 and normally is implemented as a week-long boot camp involving software developers and experts in remote sensing and business who are selected and invited to participate to the facilitated development workshop, which is taking place normally at the ESA premises in Frascati. So since 2 years, actually, we held it as a virtual edition with both pros and cons, and we will reveal some of them to you today. But we have a great heritage. Since 2012, there has been over 400 participants enlisted for the Space AppCamp, clocking an impressive 40,000 other hours of coding and delivering over 60 prototypes. So today we have a great pleasure to showcase you the solutions which were developed by the winners of the 2021 Space AppCamp. That edition was extremely rich in terms of the diversity of participants. We have 17 participants from 17 different countries. All of them with a combined background in artificial intelligence, software development, mobile apps development, remote sensing, business engineering. So our group was divided into 7 competing teams that had a challenge to develop working prototypes of mobile applications addressing several challenge topics that were put forward in front of them, and you have a list on a slide of those topics. So, as I mentioned, it was a virtual edition because of the pandemic. We had to rethink how the app could be implemented, and eventually settled on a completely new concept which we called Enhanced Mentorship Program. This program was delivered over the 8-week period, which was actually a period of both team building, ideating the actual technical and business concept of the app. And it was strongly supported by ESA Philab, where the expertise was provided to enhance the quality or Earth observation content of those apps. So this extended period also allowed to the teams that were involved in the outcome to develop much more mature prototypes of the apps. And on the other hand, we are able to bring the applications that they were working on much closer to the ongoing work at the FILA. So today we will see the presentations of the upcoming winners in the following categories: the overall winner, which is Wildfire Map, winner in the category of best sustainability impact, which is FlowTap, and then the winner in the best business idea and best data mashup, which is a FortiSky app. All of them very impressive. I wanted now to hand over to my colleague, Nicolas Langepec, who is representing ESA Philab, and who will tell you a little bit more about the whole development cycle and the role of the ESA Philab research fellows and the ESA Philab in general in this process. So, Nick, over to you.
Yeah, thanks, Anna, for this introduction. So, indeed, I'm Nicolas Langepec. I'm with the Philab. So, ESA's Philab is to accelerate the future of Earth observation. So, we aim to do transformation and innovations. And we aim to, let's say, increase and enhance the competitiveness of the European EO industries and research sectors. To achieve this mission, so we manage the full range of innovation. So we create, discover new ideas. We select, nurture some of them, and then we develop some corresponding solution. We test it, and finally we invest into the best one via the Incube program to reach the market adoption. We have two different branches at the Philab. So we have the so-called Explore Office, where I belong to. So that cover the left part of the chart that you can see, meaning discovery, nurturing, and development of ideas. And then we have this investor office managing the rest. I mean, they do invest in some SME startup and so on, so that they can accelerate their competitiveness. So I guess this whole pipeline is very well fitted to the spirit of the Space App Camp. I mean, you start with a bright blue sky ideas. You might be able to nurture it and develop it within the Space App Camp. And why not, at the end, you create your own business. So this is the whole spirit, and this is exactly what we intend to do within the Philab. So I guess this for this challenge, this summer, it was the best place to be during this summer. Next, please. So at the Philab, we mostly use AI because clearly this is transforming the global economy and many business across different sectors, industries and space, and for sure Earth observations. We believe AI has a huge potential, but still largely untapped. There are many fields to explore thanks to AI. We are, let's say, at the kind of crossroad. On one hand, we have AI becoming one of the most transformative technology, and on the other hand, we have an overwhelming amount of data which are coming from European EO sensors, commercial but also institutional from ESA, for example. In parallel, we have our smartphone. I'm sure that many of you here have a smartphone, just maybe nearby, just like in your pocket or just on your desk. In total, the number of people that own a smartphone is close to 7 billion. It's about 90% of the global populations. So this, as an Earth observation community, I mean, should be used to further disseminate our EO product, EO services, and why not also provide some feedback, some direct information directly from the smartphone user so that it can be ingested within the EO product and services. So this smartphone is clearly another way to innovate in the field of Earth observation. So this is actually the second reason why the Philab is associated to the Space App Camp, because of this cross collaboration between AI, Earth observation, and the smartphone and the mobile apps. Next, please. So at the Philab, we are conducting 3 types of activities, which are quite different in a sense. The first one is about capacity building. So we create some kind of data ecosystem so that researchers, industries, institutions can use the proper data when they need to have. We found some research and innovation activities. And the last point, which is closely related to the Space Hub Camp, is to an ecosystem building activities. And indeed, here we want to build some interdisciplinary ecosystems in Europe under a single banner of AI for EU. So I guess here within the Space Hub Camp, we had EO specialists, we are experts, we have IT software development, we have also mobile app experts. So I guess this is exactly what we are looking for, to bridge the people all together and to have like a common action under the AI for EU. Next, please. And that will be the final slide on my side is, can you switch the slide, please? Yeah, it's more or less summarizing what I've just said. I mean, Philab and Space Hub Camp, you turn some blue sky idea into viable application, up to why not a commercial business. It's really on the convergent integration of AI, EO, and mobile device as a way to innovate. And we intend to bridge the gap between the communities at large. So I guess this is the 3 message why we are part of this program, because we think it's really important and it's very key to us. Thank you. Over to you.
Thank you very much, Nicolas. So as part of the program now being 8 weeks, it allowed us to rethink also the didactical models to support this enhanced content mentoring and learning program. And here we emphasized higher order thinking, encouraging reflection on the learning process, focus on application rather than retention of theory, and also placing, as the picture here on the right shows, learners in the experience, emphasizing, of course, the importance of the application domain, the understanding the problem owner, even in this case, getting under the skin of a vineyard manager. This, together with building a community of practice, together with all the research fellows at the Philab, allowed us, together with experts such as Noam on IPR and many other business developers and app developers and AI experts, to create a community of practice supporting the different teams in their app idea and app idea validation. And of course, each of the participants, 17 in total, came with their own attitude, theory, and skills, their abilities, wisdom, but also cognition. And based on the overlap between what they brought to the table and what was needed for the app, we thought through how to satisfy their training needs in this 8-week program. So here's an example of one of the app developers that will be presenting today, how they went about understanding the customer's problem, the pains and potential gains for the customer, creating corresponding gain creators and pain relievers. And here you see feedback from one of our business developers, Pia, for a fine-grained distributed feedback in a peer-reviewed fashion. Now, we as Ramani also offered a series of online services to edit, update, and publish maps to smartphones. This slide will be shared, and the links can be, of course, explored further. Together with this technical background of getting your smartphone applications built and fed with the necessary data, the main idea, of course, is that you bring decision-ready information to the field or location where the decision maker is. And that's, of course, the unique capability of a smartphone. Now, to get there, we set up a cluster of powerful AI and big data compute facilities that we will demo in a minute. In total, all of the teams had access to an interactive development environment, which we call AI for AO. And of course, also edge AI devices with TensorLite and the new tensor processing capabilities of smartphones. You can detect from camera images, for example, what are the objects, and then potentially with a stationary device like the Jetson Nano here on the left, you could do repetitive observations, in this case in a canopy, measuring the leaf area index or the abundance of the vegetation. And instead of sending a lot of data across the internet, the inference could be run on the smartphone or on the Jetson Nano AI device to do edge AI compute and actually calculate the leaf area index and send just a small text message rather than a heavy photo. Here you see how the backend of collecting raw data, processing the raw data, and publishing the raw data to a smartphone is summarized. Yeah, so I will not show too much of the winning application, but basically this process of taking raw Sentinel imagery, processing them, adding information through AI or big geodata analytics, and then publishing it through a data access publisher was shown. Now, for me personally, the AppCamp is the yearly highlight of our professional work. Having worked for more than 25 years in the space industry and capacity building, I know that the sharp edges of AO space technologies can demotivate young enthusiasts. And I think what we have been able to offer in this 8-week program, a unique combination of situated learning experiences, also with the Philab joining this year and the Phi experience, the excellent AO data processing facilities that I just showed, and the ESA's ecosystem as a whole, offering options not only to ideate, grow, but also scale new space industry ideas, is a true pain reliever. And here you see a feedback from one of our youngest participants this year, who was also very enthusiastic about him being able to master and getting experience with Earth observation data. Initially, he found it a little bit difficult, but in the end, with all the support from the mentors and the technical support that we offered, they were able to get to a proof of concept that actually showed their solutions to the problems that will be highlighted in the next presentation in much more detail. So I would like to hand over to exactly that team, the Wildfire Map overall winner of the Space App Camp 2021. Juliana, the floor is yours. If you could share your screen.
Thank you, Valentine. Can you see it now?
Yeah, I can.
Okay. Hello, everyone. We would like to introduce you today to our app Wildfire Map. Wildfires are becoming a serious threat in the recent years, particularly because they are more and more often occurring in proximity to habitable areas where they put in danger people's life, health, and homes. You have all heard about wildfire seasons, fire-prone regions. You have seen photos and footages. You have read numbers. But have you ever imagined what it's like to be one of those people whose life have been abruptly put on hold? Let's meet some of them. I'm a homeowner, I'm a farmer, I'm a visitor. I don't know where the fire is. I don't know what was burned. I don't know where to go. One of the first things all of those people will probably do is what we all do when we need to search and to find information. Here is a search we did ourselves in August when many Mediterranean regions were in flames. Unfortunately, as you can see, there is not much that can be used here. The next thing we thought of was, what about our tools? But again, they are too complicated to be used by non-experts and on the mobile apps. Therefore, we thought that what our users will really need is an easy-to-use mobile app showing the location and the impact of the recent wildfires via accurate and timely maps specific to the user's location. With this idea in mind, before we have spent months of extensive development, we decided to test our assumption directly with some of our potential customers. We talked to people from different countries all over the world who have been in the situation of homeowners, tourists, evacuees. We had also a volunteer firefighter and even a firefighter professional. In addition to confirming that indeed there is a need for such information, they also considered the burn area to be the most important feature. Now I will hand it over to Angie, who will walk you through the demo of our app. Angie? Okay, it seems we have a problem there, but in this slide, I would like to show you a mock-up of some of the other features which we have validated during our interviews and which we are planning to use to build next. Among those are an offline version of the latest map, a family group where people can share information, and a fire report option which can utilize some of the advanced options of the smartphones. We produce all our maps using band combination indices from Sentinel-2 images, and our current product displays natural colored background maps with an overlay of hotspots and burnt areas. Our business model is built around the idea that those affected by wildfires should have available to them the information they need for their survival and for protecting of their lives and homes. Therefore, Wildfire Map will be free of charge for everyone, and it will be also free of ads. For reaching our target customers, in addition to traditional approaches, we will produce flyers with a QR code, and we will distribute those in public places such as airports, train stations, and hotels. Our market research showed that most of the existing apps are focusing on US, Canada, or Australia, and show only hotspots, but not burnt areas. Furthermore, in contrast to our app, the free apps don't offer satellite layer covering Europe, and that is where we are aiming to make a difference. I would like to introduce our team now. Andy is the main driver behind our app development. He's also the designer of our visual identity. Niels Weber is our image processing developer. He produced the satellite maps on a Ramani cloud. Luca is our in-house advisor, and he was bringing the customer point of view in our ideation and business model. My name is Juliana, and my contribution was with the data strategy, market research, and the customer validation interviews. We had never met before the app camp. We live in different countries, and we work all this time from remote. We had at the beginning many and different ideas, but we all share the common passion for developing something that can help the others. And starting from scratch, we managed to develop a functioning app in only 2 months. And of course, we were not alone in this. So I would like to take the moment here and to thank everybody who made this incredible journey possible. Our organizers and the mentors for bringing us together and being with us in every step of the process, as well as all other participants with whom we share this experience together. And thank you to everyone who is here today, and we would be happy to answer your questions. Back to you.
Thank you very much, Juliana. And of course, to all the team members on board the Wildfire Map team for this great presentation. We'll have opportunities to do a Q&A session also with anyone who has questions for you at the end. Let me switch back to Float, the winner for the Sustainability Impact Award. Federico, the floor is yours.
Yes, thank you, Valentine. I will just share the slides. Here we are. All right. Thank you, everybody, for tuning in. I'm Federico Ferlito, and this afternoon I want to show you and present you the application we developed with my team at the Space App Camp this year, together with Ivan Gentile and Konstantinos Pantats. The name of the app is Float, and it's to find and share marine debris. But let's talk first about the problem. As you might already understood, we tried to address the problem of marine pollution with our app. As you may already have read in the news, plastic debris are becoming a bigger and bigger problem with every day that passes. Indeed, there is an increasing amount of fishing nets, food wrappers, shopping bags, and more lately, surgical masks for the COVID protection. And this is a serious problem that needs to be addressed as soon as possible, as it becomes more expensive every day that passes. Indeed, there has been some estimate that for each ton of plastic, the cost for removing is between $3,000 and $30,000. So we wanted to contribute in solving this problem during the Space App Camp. And in order to first solve this problem, we just need to find the plastic, which is the most important thing. And we want to do this before it's too late and before our favorite vacation destinations become too polluted and too late to clean. Therefore, during the Space App Camp, we were put in contact with the main researcher in the area of plastic debris, and especially with the expert of the Philab, which developed the state-of-the-art in machine learning and artificial intelligence for solving such a task. And we had the chance to discover the scientific point of view on this problem, which helped us to understand better the context, but also the difficulty in solving such a task. And thanks to their knowledge, we understood that the sky is our friend, and in specific, the Sentinel-2 data is our best friend for solving such a task, as it contains and it performs a multispectral analysis of the light, dividing it into different light bands. And this can be used in different ways in order to achieve the task of finding the plastic. And this is even better for us as it has a huge field of view of 290 kilometers, and it has a free and open data policy. So let's have a look at the data that the Sentinel-2 satellite gives us here for solving the problem. On the left side, you can see the RGB image that we can extract from such a satellite. And this is very good for inspecting an area that we want to check for possible marine pollution. While in the middle area, as you can see, we increase the insight level of the view, and performing simple mathematical operations, we can compute these indices called FDI and DVI, which allow us to get more insight on the amount of plastic and debris in the sea. Even though these are simple means to improve slightly the visualization. Finally, on the right, we can see the AI prediction, which was given us by the experts of the Philab, which allow us to perform a transformation on the bands of the satellite in order to enhance the image and see where it could actually be the plastic in a better way. So you can see that as the operation becomes more complex from a hardware point of view, we get more insight. Therefore, it's important to know that with the great powers comes great responsibility. Therefore, we needed a way to put these technologies into a smartphone. And thanks to the Space Camp, we were able to do it using the AI for EO workbench, as it managed to solve the main challenges for this development, which are the easy to use computing infrastructure and the ready to use scientific and geospatial tools, which include the various machine learning tools. And the AI for EO workbench, as Valentine already mentioned before, managed to address both of these problems, as it contains both very good hardware, like clusters with NVIDIA Jetsons, which are perfect for performing these intense machine learning operations. But it also contains good software with Jupyter Hub, which allow us as a team to develop in an interactive, scalable, and flexible way, which is perfect for such a fast development. Therefore, I'm delighted to introduce you to our app called Float, which allows you to get geospatial data from the Copernicus program satellites directly to your smartphone, in such a way that you can find, report, and share satellite images to clean the oceans. But now let's have a look at how it works. In this page, you can see an overview of our analysis tool in our app. We start from the left, where the user can select an area of interest where you would like to see where or if there is a potential plastic or sea debris. After selecting the area, the user can select the date of the scan of the analysis, selecting the best image, which is the most sunny, or the latest image, which is the most recent. Because as you might know, sometimes there are clouds, so the vision might not be optimal. In the last panel, you can see a satellite image, and as you can see, the user can select between the true color, the RGB value, but also one of the two enhancements possible, so one of the indices or the AI model prediction. And as you see in the last panel, it's also possible to share these discoveries of the users. So let's have a look at the sharing tool of our app. When we were developing our product, we were thinking that this has to be useful not only for the single user, but for the whole community. Therefore, it must be important to share possible findings of people. Therefore, user can share their analysis in a sort of social network way, so that it's possible for them to retrieve them for later use, as shown on the left, but also to have an overview on a map on the right, so that it's possible to see if there are possible patterns or to have a better overview of the analysis. And this is beneficial both for the users, but also for the app itself, as the AI model in our app, it's based on supervised learning, which means that the more data we can collect, the better the AI prediction will be. Therefore, our app will help both the single people, but also the researchers and NGOs that wants to address this problem and wants to find the plastic. So now let's talk about our early adopters. There are many NGOs that are trying to address this problem, starting from the Ocean Cleanup, that is an organization that tries to build devices to collect the debris, to the Clean Sea, which address a similar task, but also to TerraCycle, which is another organization that tries to clean the coastal pollution. And our app could not only help these people and these organizations to solve their task, but also researchers and other type of people, for example, touristic resorts that wants to check whether the sea in front of their coastal area is clean or not. So after the space camp, we needed to decide what our next steps in order to deliver a good product. And these are first to polish our minimum viable product in order to contact the early adopters and test the first product in order to receive some feedback and improve the first version. But also to register the intellectual property, as during the space camp we were put in contact with experts in the field, and we learned a lot of knowledge regarding this. Therefore, we think it's a very viable thing to register our trademarks, names, logos, and so on. And finally, once we have a minimum viable product and a registered name, we would like to find fundings, for example, through incubators and investors. And that was it for our application. I hope everything was clear, and if you have any questions, I'm happy to answer at the end of the other presentations.
Thank you very much, Federico. That was a wonderful overview of what you've put together. Very impressive. I'd like to hand over to the FortiSky, our winner of Best Business Idea and Best Data Mashup Award. Marek, the floor is yours. Just to confirm, Valeria, is Marek also a co-host or panelist that can share his screen?
You would actually, but
Hi, can you hear me now?
Yes, we can.
Yes. Sorry about that. Should I turn or?
Yeah, go ahead and share your screen if you can. Otherwise, I can
Yes,
share it for you.
I can try. Sorry for the hold up.
No worries.
So hopefully you should be able to see it now.
Yeah, we can. You can put it in.
Okay, excellent. So thank you so much for coming, everyone. And I'm very happy to be able to present about FortiSky, the last but not least of the projects developed as part of this year's Space App Camp. And we called this a satellite and unmanned system solution for real-time data capture. So today it's me presenting. I'm a CTO of a company called Visgard, and along with me, and also integral part of the team is Alex Kehoe, because he's the CEO of Visgard. But unfortunately today he was unavailable. But I'm sure I'll be able to make up for it on my own, and I'll be able to hopefully answer any of your questions afterwards. So the problem we've decided to be solving is that there are countless synergies between the rapidly growing space and unmanned system markets, which are not yet being realized. So what do we mean by that, and what do we try to do? We take a look at the technologies available, and we combine multiple time-critical satellite data sources into actionable information for unmanned systems, supplemented by our onboard AI. So in practice, it means that we would use Copernicus Earth observation data from the Sentinel-1 and 2 satellites. So that's the first step. The second step, we could supplement this data, which has some limitations in terms of, for example, framing frequency, by dispatching some drones, UAVs, to investigate further. And then we would like to mission monitor in the field using a mobile app that could be, that could be deployed on mobile devices for, some sort of rescuers or coast guards, etc., depending on the mission. So here's an example user journey. So we've developed an app that
Valeria, can you try to make Marek host or explicitly? Oh no, there's a Windows restart we just mentioned. Okay, if you allow me to switch to the next presenter, which is our guest from the ESA InCube program, Piera De Vito. Piera, are you ready to briefly take over, and then we'll let
Yeah, sure.
complete their presentation after this? Great, thank you. I'm going to share my screen with you.
So,
The floor is yours, Piera.
so starting from the first slide,
So basically, in this slide, we make the bridge to your section. How do these wonderful space business ideas get the right attention, investments to find the market traction they perhaps deserve? So Piera, go ahead, floor is yours.
okay. So I'm Piera Di Vito, and I work at the Philab in the InCube program. And I would like to start with this slide to mention and to repeat what the Philab is. The Philab has been established to exploit and to stimulate favorable conditions of the European Earth observation market. And the idea is to boost innovative ideas and ethos. Maybe you don't know that the space economy is growing at the double of the global economy. And the European Earth observation service market is growing even faster. And this is due to the convergence of several favorable conditions that we call the Earth observation perfect storm. Major technology advancements are supporting and yielding richer sensors that can be sent in space at lower cost. And huge computational power is now available. And if you link that to the digital revolution, this changed the way we treat data to obtain actionable information and insights. So what happens is that this makes available to industry and to researchers more Earth observation data than before. But it's not only a matter of how much data, it's a matter of the new way. It's not only about the significant amount of data, but also is related to the way that these data are exploited by connected thinking. Because in the community is changing the paradigm, and we're moving from a centralized control freak thinking to a connected thinking. And a new entrepreneurial spirit in Earth observation is generating innovative business models, making the Earth observation the new home for large risk capital investment. Next slide, please. So also in this slide, basically, I summarize what I already finished to say. So it's not only a matter of data, but it's a matter of intelligent decision-making and commodities, business, scientific insight, and analytics. That's the perfect storm. Next slide, please. So we're going from Earth observation to Earth insights and analytics. And next slide, please. So the Philab. What is the Philab? Our purpose is to accelerate the future of Earth observation via transformational innovation. So in the Philab, within the Philab, we have the Explore Office, who has a research focus, and it has the task of explore and discover, nurture good ideas, and they have the fail and fast ethos, and then the Incubed program that is as part of the Invest Office where I am. And within Incubed, what we do is that we support the development of mature, and we support the maturation of the solution, invest, because our scope is also to foster industrial entrepreneurial initiatives, and then accelerate European Earth observation competitiveness. So what we support is the development of a minimum viable product, which is market-driven, customer-driven. So if in Explore Office, they have the research focus, in Incube, we have the commercial focus, and we work all together within the Philab. So next slide, please. In the Incube, we invest in the industrial innovation. So what is Incubed? It's an industry-led commercial program in Earth observation. Today we have 18 countries and a total budget of 103 million euros. As I said, the focus is to develop innovative and commercially viable products and services based on strong customer engagement. All the ideas shall be commercially sustainable. So what you're proposing shall really be customer driven, shall find its space in the market. We're based in ESRIN, and we work in tandem with our colleague in ESTEC. What we support? We support the development of anything from building satellites to data platforms, flight hardware and software. And we look really at innovative business models, of course, within Earth observation domain. The TRL, the technology readiness level that we look at, span from 4, and we hope to help you to go up to 8, 9. When you can apply always. It's an always open call. And how it works. It's supported by ESA, by us, together with the national delegations, and of course industry, because this is a co-funded program. So we put typically the 50% of the cost, and the industry, the remaining 50%. For the SMEs, the co-funding can go up to the 80%. Currently, we have 60 activities, and the price range goes from 150K to 17 million euros. Next slide, please. I hope that arriving at this slide, it's clear for you that our scope is to stimulate and develop the Earth observation commercial sector. We don't provide only co-funding, which is already something, but of course we offer you our guidance and our know-how. And of course, who works with Incube has the ESA stamp credibility and the opportunity to access to ESA Earth observation facilities and the Philab and investor partnership. So for those who has an interesting ideas which can match the criteria I mentioned in the previous slide, we strongly encourage you to pitch your idea to Incubed. And we will set up a video meeting to listen to you. Next slide. I will try to speed up because I'm a bit late, I think. So I wanted just to provide a showcase of some of the projects we have. I go very fast, not because they're not important, but just because I said we're running out of time. So for example, we have Aerospace Lab, leading a multispectral companion satellite prototype that aims to generate optical data sets, aiming to complement Sentinel-2-like data products with a daily global coverage, or SAT for EO critical elements. It offers very high resolution payload, TDI CMOS detector, agile AOCF, ground processor, and exploitation platform. And then Impulsion, that is focused on the development and qualification of testing of a high reliability version of electric propulsion IFM nano and microcuts thruster. And Mantis, mission and agile nanosatellite for terrestrial imagery services, focused on serving the energy sector. Next slide, please. And then we have Hyperscout 2 for the FSS CAT mission. It's a miniaturized hyperspectral and thermal imaging coupled with artificial intelligence for breakthrough operational space mission. And as I said, these are all co-funded projects. And you can see in each of the project the partners of the consortium. And I would go to the next slide. And again, here I would mention SAT4Flood is an online platform to globally visualize the level failure risk, combining high resolution soil moisture info with INSAR deformation data and other EO data. Because as I mentioned before, we support from downstream to upstream activities. For us, what is important is the key role of Earth observation and the commercial sustainability, and of course, the technical credibility and feasibility. And since we're really running out of time, I would move to the next slide. So the contract which have been signed here this week is the AI for Earth Observation Solution Factory proposed by the FKI. And the team is quite happy with this achievement, and set up an artificial intelligence powered solutions factory, de-risked and supported by the InCube program, generating commercially viable Earth observation products and services. And if you're wondering what de-risked means, the way we propose the company to work with is to follow the so-called, or the de-risking phase. So where you investigate the technical and commercial feasibility before jumping into the product development. You can choose to follow these two phases or to select just one. It really depends from how comfortable and the maturity of the idea. And then next slide, please. So this is InCube right for me. As I said, and I hope to not repeat too many times myself, but if you have a commercially focused Earth observation-based product or service that you would like to propose, and you feel that is innovative and has the potential to become commercially sustainable, indeed, InCube can be a really great tool to help you to de-risk your development. What we want to do is to support the idea up to at least the minimum viable product level. And then for us, often industry asks us, okay, but why ESA interested? For us, the interest is we help you to start to generate revenues then. So it's sustainable commercial, and then your business case really works. That's where we win. And then can you please move to the next one? I hope I provide you at least a flavor of InCube, and we would like to invite you to the InCube Investor event, Philab and InCube Investor event next year on the 20th and 21st January. And during this event, we will bring Earth observation commercial industry together with private investor and venture builders. Please visit incubed.fi.esa.int. And do not hesitate to contact me should you have any question or interest. Thank you.
Thank you very much, Pia, for the very nice introduction on the INVEST program, and what you've put together, Pierre, is very impressive for scaling this new space business idea. I'd like to hand back the floor to our last, but not least, winner of Best Business Idea and Best Data Mashup Award, FortiSky. Go ahead. The floor is yours, Marek.
Okay, excellent. Sorry about that hiccup previously. Yeah, I got punished for working all the time and not using Windows Update, so now it's force updated. Well, anyway, so just to pick up quickly, so our workflow is we detect data from satellites, then we can send over a drone, and then we can monitor the mission on a mobile app. And so this is how it looks like. To pick off where I left, we get the data from AIS, which is a protocol that all ships have to transmit, and we correlate it with what the satellite sees. So the green dots are ships that kind of look like what they are transmitting, and then we have yellow triangles that show ships that, you know, are somewhat suspicious in the sense of like they transmit something different than what they look like, or they don't transmit at all and the satellite sees them. And then we also can say, we can send over a submarine or a drone and also combine it with the onboard data. So for example, a video feed from the submarine or a drone or anything. You can change it to a drone here, you can see. And so it's a 3D app, and you can kind of monitor the mission of which could be, you know, search and rescue, trying to find some survivors on some debris on the sea or anything else. So I think that's that pretty much sums up what we do. So before the Space App Camp, we had some sort of a map with pretty much like you might be aware of like flight radar. So we had the flight paths of different planes, and then we during the Space App Camp we developed AI to, you know, to recognize ships, correlate them with the ASI AIS, sorry, signals. We made a timeline replay to replay it in the future as well, and did 3D tracks of unmanned systems that are sent to investigate. So moving on, we also are cooperating with some unmanned system providers. So we don't make drones ourselves. We would cooperate with other startups, basically companies that do that. So Marble Aerospace, they find illegal smuggling in Africa, for example. Liam, they provide firefighter support and wildfire detection. Or Snotbots, they are actually monitoring whale health from their blow. So primary revenue for the business model would be some revenue coming from the internet connected computer vision device, and then another form of inflow would be software as a service, which is access to curated and timely satellite data, which would also has a price. And a secondary source could be some buying and reselling of data sets. We would also support open source science. So we've noticed the project CMEMS, which includes, you know, many data sets based on, you know, tide gauges, profiles, gliders, blah, 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 which is amazing. But we could also add a new data set of unmanned systems and basically add footage, for example, from a drone approaching a vessel, which could be then used to further improve some models or scientific models, etc. We also have tested, so this was during the Space App Camp, this was in the future, but now it's happened. We've tested the system on a real unmanned submarine last week, which was very successful, and the Royal Navy was quite impressed. So hopefully we can take this further and for them as well. And our plan is basically to partner with established companies, exhibit at trade shows, and establish these via LinkedIn. And hopefully we'll be able to turn this into a real product that's real customers will have interest in, especially when compared to the, let's say, competition. There are other products that try to do similar things, but none of them combine all of the things together that we do. So Earth observation detection, then AIS data fusion, then drone solution for follow-up investigation in real time, and then also having a mobile app for responders. Then as part of the Space App Camp, we did some revenue projecting, and hopefully this can be realistic, but it's not the focus today, so I'll skip that. And then just the background. I'm Marek from Prague. My background is in technology, so I developed part of the AI and the mobile app. And then we also have Alex, who's based in London in the UK, who's a former Royal Navy engineer. So he has also a lot of technical experience, but also is doing the business side. So right now we're looking for first customers for paid trials to basically showcase our initial prototype so that hopefully we can grow and customize our concept together. And we'll definitely be also considering some of the mentioned possibilities of the file app, such as Incubed, etc. So hopefully let's use Earth observation data to save lives and protect the environment together. Yeah, we identified untapped potential, combining UIS and Earth observation data. We designed a mobile application using this and AI, and FortiSky is what we call the developed product. So thank you for your attention, and if you ever need to contact us or if you're interested, feel free to ping us at the information in the bottom right.
Well, that's great to hear about what you developed, Marek. Very impressive. Thank you so much. Now, probably this is also the appropriate moment to thank all the co-organizers such as AZO. Here on this call is Cristina Ramos. Cristina has been facilitating the logistics and the communication and marketing aspects of the Space App Camp 2021. A big thumbs up for what you've done. Thank you again. And I think it also is probably the right moment to thank our colleagues such as Firman, Anna, Paola, Barretta, and Laura, and all the others at ESA, such as the Philab Research Fellows, and Nicholas. Here on board, we also have James Wheeler, who was very instrumental as a research fellow, sharing his thoughts and suggestions with, for example, the overall winner of this year's AppCamp, the wildfire map. I think this brings us to the closing session. Just for you who might be interested in doing the same, join us next year. Hopefully there will be a new iteration in 2022. Check the address shown to see when the call for new applicants is over. Come alone or come together with a team, and hopefully we can do amazing things together again. I'd like to open the floor for anyone who has questions or comments. Please raise your hand. I don't see anyone raising his hand, so I think with this we can close this side event of the 2021 edition of the Phiweek, giving you an overview of what we've done at the Space App Camp 2021. Thank you all for joining and presenting. Thank you all for being part of this amazing journey. Thank you all for the teams that presented today, and hope to see you in cyberspace, but preferably at ESA ESRIN next year.
Thank you very much, Valentin. This was great. Thank you for chairing and for making this event such an interesting closure of the Space App Camp. So see you next year.
Thank you. Bye-bye.